My name is Ravi Prakash, and this is the sixth class of remainders. Okay, so in this sixth class, we'll discuss a concept called reverse Euler, right? Now, see, reverse Euler is a concept you won't find in any book and all. You won't find in any book, right? But it is a name given so as to counter some very tough problems of remainders, right? In which the powers are very close to Euler number, but before it, not after it, right? For example, I'll tell you. See, if the question is if the question is 50 raised to 53 divided by 53 remainder, it is very easy, right? It is very easy because what you do, you can directly apply Euler theorem here because 50 and 53 are co-prime. So 50 by 53 remainder and 53 by 52 remainder, right? Because 52 is the Euler of 53. 53 is a prime number. It's quite easy here. What is the remainder here? This remainder is what? This is 50 only. So 50 raised to 1 is 50. Quite easy, right? If I make 50 raised to 52 by 53 remainder, it is again very easy. Why? Because 50 by 53 remainder and 52 by again 52 remainder, because again 52 is the Euler of 53, right? Again it is 0. So 50 raised to 0, what is the answer? In this case, answer is 1. In this case, answer is 50, right? These questions are very easy because this 53, Euler is 52. And denominators, powers here are what? Just 52 equal to 52 or just more than 52, right? But what if the question becomes 50 raised to 51 divided by 53 remainder? Now it's a tough question. It's a really tough question, right? But you can solve it very easily within 20-30 seconds if you get the concept, right? But this is what I meant by reverse Euler, because now if you apply Euler theorem here, so 50 by 53 remainder, okay, and 51 by 52 remainder. Now you can't do anything here, right? Because 51 by 52, what is remainder? 51 only. So power is not diminishing. The motto of Euler theorem is, when you apply Euler theorem, that means you divide the power by the Euler number, power gets diminished, right? And it's very easy for us to solve. But in this case, if the power is just less than the Euler number of denominator, right? Because 53 Euler is or 52 and 51 is just less than 50. If the powers are 50 here, right? Or like the question like this also, 50 raised to 50, okay? So now this becomes very tough questions now, right? So for this, we'll discuss a concept of reverse Euler, right? Reverse Euler means just back to Euler, right? So we'll go through Euler number, we'll go reverse it, right? That's why. So get this concept now. Very important concept. Please listen carefully, right? See, I'll tell you. See, suppose I write 14 by 3 remainder. If I write, right, I know what is the answer. Answer is 2. 14, 3, 4, 12, remainder is 2, right? But actually, what is the form of the number? A number when divided by 3, remainder is 2. That means this 2 is of the form 3k plus 2. This 2 is of the form 3k plus 2, right? A number when divided by 3, remainder is 2. So what is the form of the remainder? 3k plus 2. Form of the number or remainder, right? It is 3k plus 2. So what is 3k plus 2? So for a smallest value of k, we get remainder as 2, right? That means at k equal to 0. For smallest value of k, that means at k equal to what? At k equal to 0, right? So you get remainder as 2. Fine. So for this smallest value of k, we get remainder as 2. Now, so that remainder, now understand this, that remainder has a form. Remainder has a form, right? Every line, please listen carefully and understand it, right? Remainder has a form. What is the form? Same as the number. That means a number when divided by 3, remainder is 2. So number of the form 3k plus 2. Okay. And a smallest value of k will give the remainder of 2 here, right? Now this concept, that this form of remainder, I'll use to solve those tough problems, right? See here now. If the question is 50 raised to 51 divided by 53 remainder, 53 remainder, right? What will happen here? If I apply Euler, so I know that 53 Euler is 52, right? So first what I'll write, okay, I know that 52, if it was 52 here, the answer was surely 1, right? So I know that answer would be surely 1, right? I'm solving, see, the question is 50 raised to 51 divided by 53 remainder, okay, and I'm solving it. So I know that 53 Euler is 52, so I know that 50 raised to 52 by 53 remainder will be 1. Now what I need here, I need is 50 raised to 51, right? What I'll do, I'll split it, I'll write like, okay, 50 into, sorry, 50 raised to 51 into 50, right? This 50 raised to 52, I can write like this. So 50 raised to 51 into 50 divided by 53 remainder. And now here, you write the form of the remainder, right? What is the form of the remainder? So a number, this we get as 1, right? How we get as 1? So what is the form of the remainder? So what is the form of a remainder? Remainder has a form. So form is what? A number when divided by 53, remainder is 1. So remainder is of the form 53k plus 1. Remainder is of the form 53k plus 1, right? You can write this step here. Instead of 1, you can write 53k plus 1, right? Fine. Now 50 raised to 51 by 53, this remainder I want. This is the question, this I want, right? Now 50 by 53, what is the remainder? So 50 by 53, what is the remainder? Remainder is what? Minus 3. Minus 3, right? Now that means that minus 3 will come here. Understand that? Understand this logic. This minus 3 will come here in divisor, right? Because it is a multiplication. This will be like divided by this minus 3 now, right? But I want this number, so but remainders are always integers, right? Remainders are always integers, right? So I want this number to be, I want this 53k plus 1 to be divisible by 3. For such, write such a value of k such that it is divisible by 3. If you observe for now, say I'll tell you the method also, but if you observe for now, at k equal to 1, it is divisible by 3, right? At k equal to 1, it is divisible by 3. Okay, so at k equal to 1, that means 50 raised to 51, okay, 50 raised to 51 divided by 53, okay, divided by 53, fine, we write here. So 50 raised to 51 divided by 53 remainder, right? What it is? At k equal, if you put k equal to 1 here, it becomes 54, and 54 divided by minus 3, it becomes minus 18, right? So what you get here? You get that 50 raised to 51 by 53. What is the remainder? Remainder is what? Minus 18. But remainder can never be negative. Final remainder, it is always positive. Just add in base with sign. So 53 minus 18. What is the answer? Answer is 35. So 35 is the answer for this super duper question. 35, right? And there's a whole logic, right? See, if it's a tough question, logic is also good, right? But once you get this logic, it's my promise that we'll solve this in 30 seconds. We'll do lots of problem now, right? But have patience. You have to be patient here. I know it's a tough problem, right? I'll again repeat it. See, question was 50 raised to 51 by 53. What is the remainder? So now 50, I know that Euler of 53 is 52. So 52 by, if it was 50 raised to 52 by 53, remainder is 1, right? And there from here I go reverse. This is reverse Euler, right? I'm going reverse now because I know I need just one number before 52, that is 51. So I split it 50 raised to 52 as 50 raised to 51 into 50, because this, what is this? This is what required, right? Required. 50 raised to 51 by 53 is required. Okay. Now into 50. So now 50 by 53, what is the remainder? Minus 3. And this one, you need to write now in form. Remainder has form, right? Like here, remainder was 2. So what is the form of remainder? Form of remainder is what? 3k plus 2. A number when divided by 3, remainder is 2. So now remainder is of the form 3k plus 2. And for a smallest value of k, you will get remainder as 2. Okay. That means here also 53k plus 1. I'll write form y, because a number when divided by 53, remainder is 1. So remainder is of the form 53k plus 1. Now, Since this minus 3 is extra in this left hand side, is in multiplication. Simple logic, this minus 3 will come in denominator here. Right? It will come in denominator here. Right? For this to be minus 3, I don't want any fraction here. 53k plus 1, I don't want divide by minus 3. It remains any fraction because remainders are always integers. Right? So I'll just observe it. So I want a number of the form 53k plus 1 such that it is divisible by 3, such that what is this minus 3 is this only, right? So such that it is divisible by 3, right? At what value it is divisible by 3? Simply observe that at k equal to 1 it is divisible by 3, right? Because it becomes 54. At k equal to 0 it is not, it is 1. At k equal to 1 it is what? It is 54. So 54 by minus 3. So 50 raised to 51 by 53 is left at left hand side. Okay, in right hand side minus 3 will divide this 54, it has become minus 18, right? So then here, so then 50 raised to 51 by 53, what is the remainder? Minus 18. But final remainder is never negative. You always add to remainder it with base, right? So minus 18 plus 53, what is the answer? So minus 18 plus 53, answer is what? 35. So 35 is the answer, right? Now one more thing I'll tell you in this one, right? Once you write this step that okay, 50 raised to 51 by 53, the remainder is 53k plus 1 divided by minus 3, right? So what we are searching is that, okay, so we wrote this step here. This step I told you, right? See, 50 raised to 51 by 53, what is the remainder? Remainder we wrote it as 53k plus 1 divided by minus 3, right? Now 53k plus 1, I want it to be divisible by 3, right? So what in this case I told you, okay, the first method is what? Simply observation, that I want a number of the form 53k plus 1 which is divisible by 3. So we observed that, right? We observed at k equal to 1 it is divisible. Now second way, we can use a method to solve it, right? Again, this is a method. So what I want is 53k plus 1 to be divisible by 3. To be divisible by 3 means what? If it is to be divisible by 3, what is the remainder? Remainder has to be what? 0. So if it is to be divisible by 3, the remainder has to be 0, right? So now 53 by 3, what is the remainder? So 3 into 18 is 54, so it is minus 1. So it is like, and what is 1 by 3 remainder? 1 only. Okay, that is minus 1 into k plus 1 divided by 3, the remainder is 0. That means for 0, you can simply observe at what value of k you will get this numerator. Now this numerator should be, right, this numerator should be either 0 or multiple of 3, because any multiple of 3 by 3 will give me the required remainder as 0, right? So either it should be 0, either numerator should be 0, or it should be multiple of 3, right? So at what value of k I'll get 0? Simply we can observe that simply at k equal to 1. At k equal to 1, we'll get numerator as 0. We'll get numerator as 0, that means remainder as 0. That means k equal to 1 satisfies, right? So if k equal to 1 I put here, so that means at k equal to 1, what is the answer? 54 by minus 3, that is minus 18. Hence the answer will be what? 35, right? So it's a very good method here, right? This is a very good method. This is how to solve, because in many cases I simply can't observe, right? Okay, 53k plus 1, at what value of k I'll get a required remainder, right? To be divisible by 3 sometime, or divisible by 7 sometimes, right? So many hidden trial I need to do. So earlier also same concept I was explaining in Chinese remainder theorem also, right? How to solve this, right? To solving this is very important. Okay, now let's do one more question. 7 raised to 99 divided by 101 remainder. Now again a similar question, you can simply observe here that 101 is a prime number and 101 Euler will be 100. Okay, and power has got 99. Power is 99. So 99 by 100, again power is not diminished. So Euler's theorem purpose is not solved, right? So in this case, again what we'll do? Again same thing I'll do. I know that if denominator is 100, right? So if denominator is 101, so 7 raised to 100 will perfectly give me a remainder of 1. Will perfectly give me a remainder of 1, right? And now you can split this, right? We can split this because I want 7 raised to 99. So what I can do, I can do 7 raised to, I can write 7 raised to 100 as 7 raised to 99 into 7 raised to 1 divided by 101 remainder. I can write like this. Okay. Now 7 raised to 99 by 101 is required. Okay. 7 raised to 99 by 101 is required. Now 7 is extra. So 7 by 101 remainder is 7 only. This 7 will come here in denominator. What it is the numerator? So numerator remainder is 1. But numerator I want a number which is divisible by 7 because 7 will come here. So I want a number in numerator that is divisible by 7, right? So for that I need to write not actual remainder. I need to write the form of remainder. So what is the form of remainder here? So a number when divided by 101, remainder is 1. So what is the form of remainder? 101k plus 1. Okay. So 101k plus 1. And now what I want that at what value of k it will be divisible by 7, because when 7 will come here, when this 7 will come here, I want that this number is to be, this numerator to be perfectly divisible by 7, right? Again, if you can observe it, it is well and good, right? You can we can observe it, it is well and good. Otherwise we have the method to solve it, right? What is the method? So the method is 101k plus 1 should be perfectly divisible by 7. That means what is the remainder? Remainder should be what? 0. Now 101 by 7. Okay. So 14 7 are 98. So 14 7 are 98. What is the remainder? 3. That means 3k plus 1 by 7. That remainder should be 0. Now at what value of k I'll get the remainder to be 0? Simply I'll observe at k equal to 2. That's very easy now, right? 3k plus 1 by 7, remainder should be 0. So at k equal to 0, it is 1. At k equal to 1, it is 4. 4 by 7, remainder is not 0. At k equal to 2, it is 7. So at k equal to 2. At k equal to 2, right? So very quickly we'll get this value at k equal to 2. So I can simply put k equal to 2 here. K equal to 2. So it becomes what? It becomes this 7 raised to 99 by 101 remainder is equal to, actually we should write like this, is equal to 101k plus 1 divided by 7, right? And at what value of k this will be divisible by 7? We got at k equal to 2. So at, if I put k equal to 2 here, okay, k equal to 2, what I'll get? I'll get 203, right? 203 by 7. What is the remainder? 203 by 7. What is the remainder? It goes 29 times. So what is the answer? Since 29 is positive number, so 29 only would be the answer. So answer for this question is what? 29. So 7 raised to 99 upon 101 remainder. What is the answer? Answer is what? Answer is 29. Okay. Same method we are doing. Same method, right? Reverse of Euler. These all are same model questions. These are tough questions of remainders, right? In CAT, many times in previous year questions, remainders question has been asked, right? Sometime you apply Euler, sometime you can apply Chinese, sometime normally also we can solve by simply negative remainder because questions are easy, right? So remainders variety they ask in CAT and ZAT or all this kind of exam, right? This question has got a beautiful logic, right? That's why this becomes a very important question. Okay. Now one more we'll do, right? We'll practice lots of questions so that I can absolutely command the concept, right? Now the next question we'll do is 12 raised to 107 upon 37. What is the remainder? 12 raised to 107 by 37. What is the remainder now? Again, logic here again is same, right? If you observe it, Euler of 37 is 36. And if you divide 107 by 36, what is the remainder? 35, right? So again, a huge number, right? Don't write -1 because in power, I can't write negative remainder. Okay. So 107 by 36. What is the remainder left? 35. So again is a huge number, right? And I can observe that 37, what is the Euler of 37? So Euler of 37 is what? 36. So 36 multiple is 108. So again it is just one step behind Euler number. That's very tough to solve, right? So again same thing we'll do. I know that Euler of 37, I know that Euler of 37 is equal to 36. So if Euler of 37 is 36, so it means that 36 multiple is what? 36 multiple is what? 108. 36 multiple is what? 108 near 107, right? It is 108. So in this case for 108, right? So I know that now 12 raised to 108 by 37, the remainder would have been perfectly 1 because 37 was perfectly divisible by Euler of 37 was perfectly divisible by 108. Okay, now again I'll split it, same funda, I'll split it, or 12 raised to 107 into 12 upon 37, that remainder I want to be 1. But again for this, since this 12 will come here in denominator, right? So now I have to write the form of the remainder because remainder can't be in fraction, so I can't write 1 by 12. Okay, so for this number to be divisible by 12, okay, this number I need to write the form of remainder. What is the form of remainder here? A number when divided by 37, what is the remainder? 1. That is 37k plus 1. Okay, that basically means that, or 12 raised to 107 by 37. What is the remainder? That is 37k plus 1 by 12. So to observe at what value of k, right? At what value of k, I'll get that number, that numerator to be, this numerator should be what? It should be divisible by 12. So at what value of k will it happen? Again same thing I'll do. 37k plus 1 should be divisible by 12. That means what is the remainder? Remainder should be 0. Okay, so 37 by 12, what is the remainder? K. 37 by 12, what is the remainder? K. So that means k, 37 by 12, what is the remainder? 1. So this will become, actually this I wanted to say, that 37 by 12 remainder is 1. So 1 into k is k. So k plus 1 by 12 remainder is 0. This will happen at what value of k? This will happen at what value of k? It will happen, right? It will happen at k equal to 11, right? At what positive value of k? It will happen at k equal to 11, because 11 plus 1 is what? 12. 12 by 12 is what? Remainder is 0. This will happen at k equal to 11. That means I should simply put k equal to 11 here. So 37 into 11 plus 1 by 12. What is the answer? So this is 408 by 12. What is 408 by 12? It becomes 34, right? Therefore 12 raised to 107 by 37. What is the remainder? Answer is 34. So 34 is the answer, right? So on same model I have discussed 3 very good questions, right? Explaining you the reason why I have to use reverse Euler here. Okay, so these are very tough questions of remainders. You can do it very easily once you get this concept. Try these 3 questions at least 3-4 times each. And then I've given similar such 3-4 questions on reverse Euler in the quiz, right? Kindly solve it. Okay, before seeing my video solution of quiz, you have to solve it. Okay, so you'll get it. Okay, thank you.